Have you ever wondered how Earth got its moon? For decades, the most popular theory has been the giant impact hypothesis. This idea suggests that about 4.5 billion years ago, a planet-sized object called Theia collided with Earth, and the debris from that impact eventually formed our moon. It's a theory that's been widely accepted by scientists, especially because of the evidence we gathered from lunar rocks brought back by the Apollo missions. These rocks share many chemical similarities with Earth's rocks, supporting the idea that the moon was once part of our planet. But now a new theory has emerged and it's shaking things up. Some scientists are suggesting that the moon wasn't formed by a collision at all. Instead, Earth might have captured the moon during a close encounter with a binary system, two objects that orbit around each other. Here's how this fascinating theory works. In a binary system, you have two large celestial bodies, like planets or moons, orbiting one another. According to the new theory, Earth may have passed close to one of these systems billions of years ago. As Earth's gravity interacted with the binary system, it could have pulled one of the objects into orbit, leaving the other to drift away. That's how Earth could have captured the moon and made it its satellite. In fact, we see evidence of similar captures elsewhere in our solar system. Take Neptune's largest moon, Triton, for example. Scientists believe Triton was once part of a binary system in the Kuiper Belt before Neptune's gravity captured it. Today, Triton orbits Neptune in the opposite direction of the planet's rotation, which is a strong clue that it was captured. So, what makes scientists think this capture theory could apply to Earth's moon? One clue lies in the moon's orbit. If the moon had formed from the debris of a massive collision, its orbit should be perfectly aligned with Earth's equator, but it's not. Instead, the moon's orbit is tilted slightly, more in line with the sun than with Earth's equator. This misalignment suggests the moon's journey to Earth might have been more complex than the simple collision theory explains. Another interesting aspect is the moon's elliptical orbit. The new theory proposes that when the moon was first captured, its orbit was much more elongated or elliptical. Over time, tidal forces between Earth and the moon caused the orbit to gradually become more circular, which is the shape we see today. These same tidal forces are why the moon is slowly drifting away from Earth, about 3 centimeters each year. While this capture theory is still new and hasn't replaced the impact hypothesis, it opens up exciting new possibilities. It's a reminder that the story of our moon is far from settled, and there's still so much to learn. Scientists will continue to study the moon's orbit and composition to gather more evidence that could confirm or challenge this theory. So what do you think? Was the moon once a wandering object in space before it was pulled into Earth's orbit, or was it born from a massive collision with our planet? As scientists continue to explore these questions, we get closer to understanding not just the moon's origin, but the processes that shape our entire universe. Let us know your thoughts in the comments, and don't forget to like and subscribe for more fascinating science content. Stay curious and keep exploring the wonders of space.